Tempest 战斗机项目的历史、现状与未来概述。1. 项目概述。Tempest 战斗机是由英国BAE系统公司主导开发的一款第6代战斗机，预计于2035年正式投入使用，旨在替代现有的欧洲台风战斗机 Eurofighter Typhoon。该项目是未来作战航空系统 Future Combat Air System FCAS 计划的一部分，涉及多方合作，包括英国国防部、BAE系统、罗尔斯、罗伊斯、Rolls-Royce、意大利莱昂纳多、Leonardo 及 MBDA 等。2. 项目历史与发展。1. 概念发展。Tempest 的战略概念自2015年开始发展。2018年，英国国防部发布了其空中战略，强调继续推进 Typhoon 的开发，并实施 FCAS 技术计划。2. 国际合作。2020年，意大利和瑞典签署谅解备忘录，承诺探索与 FCAS 的合作。2022年，英国与日本达成共识，决定共同开发发动机和雷达原型，最终将 Tempest 与日本的 FX 战斗机项目整合，形成全球作战航空计划 Global Combat Air Program GCAP。 3. 技术与设计。 Tempest 将采用多项前沿技术，包括深度学习人工智能、无人驾驶能力、群体无人机、定向能武器以及虚拟驾驶舱等。该机设计为模块化，以便于适应不同任务并进行升级。 4. 财政投资。英国政府计划到2025年投入20亿英镑用于该项目的初始阶段。意大利也计划到2035年投入总计77亿欧元用于 Tempest 的开发。 3. 时间线。2015年 Tempest 项目的战略概念开发开始。2018年7月，英国国防部发布空中战略，介绍 Tempest。 2019年7月，英国与瑞典签署谅解备忘录，探讨共同开发第6代战斗机。2019年9月，意大利正式加入 Tempest 项目。2020年，意大利和瑞典与英国签署 FCAS 合作的3方谅解备忘录。2021年12月，英国与日本达成共同开发发动机的协议。2022年，宣布 GCAP 计划整合英国、意大利和日本的战斗机项目。2023年10月，意大利国防部提出新的预算方案，显著增加对 Tempest 的投资。4. 设计特点。 Tempest 战斗机将具有多种先进设计特点，包括模块化设计，便于角色适应和升级；隐身技术，减少雷达反射面积；无人驾驶能力，可在无人状态下执行任务；群体无人机操作，通过控制多个无人机进行战斗；深度学习 AI， 提升战斗机的自主决策能力；虚拟驾驶舱，通过头盔显示器提供信息，增强飞行员的感知能力。5. 未来展望。 Tempest 项目的未来充满了挑战与机遇。尽管面临技术与财政上的压力，随着国际合作的深入发展，各国的投资和参与将为项目的成功奠定基础。Tempest 不仅是替换现有战斗机的计划，更是推动航空技术革新和国际防务合作的重要平台。预计在未来10年内 ，Tempest 将逐步进入开发和测试阶段，最终形成具备战斗力的第6代战斗机。6. 总结。 Tempest 战斗机项目体现了现代航空技术的前沿发展，结合了国际合作与创新技术，旨在确保英国在未来空战中的竞争力。通过集成来自不同国家的资源和技术， Tempest 将成为全球作战航空能力的重要组成部分，为未来的空战环境做好准备。
The Tempest Fighter Jet project, spearheaded by BAE Systems in the UK, represents a significant evolution in military aviation, aiming to establish a sixth-generation fighter by 2035. This initiative is part of a broader strategy to enhance air combat capabilities through international collaboration and cutting-edge technology. The following points illustrate the counterintuitive aspects of the Tempest project and its implications for the future of military aviation. 1. International collaboration versus national sovereignty. While the Tempest project involves multiple countries such as Italy and Japan, it raises questions about national sovereignty in defense. Traditionally, nations develop their own military technologies to ensure independence. However, the Tempest project illustrates a shift towards shared development, suggesting that global security challenges necessitate collaboration over isolation. This could lead to a future where nations are more interdependent in military capabilities, which counters the conventional wisdom of self-reliance in defense. 2. Artificial intelligence in combat. The integration of deep learning AI and autonomous capabilities in Tempest signifies a radical shift in how combat aircraft are operated. The idea that a pilot could rely on AI to manage flight controls or even make combat decisions is counterintuitive to traditional military training, which emphasizes human judgment and experience. This reliance on AI could fundamentally alter the nature of air combat, pushing the boundaries of what is considered acceptable in warfare. 3. Modular design for adaptability. The Tempest's modular design allows for rapid upgrades and adaptations, which contrasts with the traditional approach of developing a singular fixed design for a fighter jet's lifespan. This flexibility suggests a future where military hardware is continuously evolving rather than being static, challenging the notion that once a system is deployed, it remains unchanged for decades. 4. Financial investment in defense. Amid economic uncertainty, the scale of financial commitment from the UK and its allies towards the Tempest project may seem counterintuitive in a world where many countries are facing economic challenges. The UK government's allocation of £2 billion for the initial phases and Italy's proposed increase to €7.7 billion by 2037 highlight a prioritization of defense spending over other pressing economic needs. This signifies a long-term strategic vision that prioritizes military readiness even when immediate economic pressures may suggest otherwise. 5. Integration of directed energy weapons. The planned incorporation of directed energy weapons into the Tempest design challenges traditional concepts of air-to-air and air-to-ground combat. These weapons represent a paradigm shift in how engagements might occur, moving away from kinetic options to more futuristic non-kinetic solutions. This shift raises questions about the ethics and legality of warfare, as well as the implications for international defense treaties. 6. Biometric monitoring of pilots. The proposal to utilize biometric data to monitor pilots' physiological states and enhance performance through AI assistance is a notable departure from conventional pilot training practices. This idea suggests that future combat operations may increasingly rely on technology to support human operators, potentially leading to a scenario where pilots are augmented by technology rather than solely relying on their training and instincts. 7. Impact of global threats on defense strategies. The Tempest project's accelerated development timeline, reflecting geopolitical threats like the Russian invasion of Ukraine, underscores a counterintuitive reality. Military responses are often reactive rather than proactive. This indicates that defense strategies may be increasingly shaped by immediate threats rather than long-term planning, suggesting a shift in how nations prioritize and justify military investments. 8. Environmental considerations in military aviation. The development of advanced engines and the focus on using lighter materials for the Tempest can be seen as a counterintuitive response to the growing emphasis on sustainability. Traditionally, military projects have not prioritized environmental concerns. However, the acknowledgement of climate change and its implications for global security is forcing military programs to adopt greener technologies, challenging old paradigms of military procurement. In conclusion, the Tempest project embodies several counterintuitive trends in military aviation, from international collaboration and reliance on AI to a shift in financial priorities and environmental considerations. These elements not only redefine the future of combat aircraft but also reflect broader changes in how nations view defense technology and cooperation in an increasingly complex global landscape. The Tempest Fighter Jet program represents a significant advancement in military aviation technology and international defense collaboration, yet several crucial elements within the report may be overlooked by most readers. Here are the important content aspects that warrant deeper exploration along with their significance. 1. International cooperation and strategic alliances. The Tempest program is not just a UK initiative, it has evolved into a multinational effort involving countries like Italy and Japan. The merging of the Tempest project with Japan's FX fighter project under the Global Combat Air Program GCAP is particularly noteworthy. This collaboration signifies a shift towards greater international cooperation in defense technology, which can lead to shared research, reduced costs, and enhanced interoperability among allied forces. Significance: this international dimension highlights the geopolitical landscape's complexities and the need for countries to collaborate on defense technologies to counter emerging threats. It reflects a broader trend in defense procurement where nations recognize the importance of pooling resources to develop cutting-edge military capabilities. 2. Technological innovations. The incorporation of advanced technologies such as deep learning AI, unmanned capabilities, swarming drones, and directed energy weapons sets Tempest apart as a sixth-generation fighter. The virtual cockpit and AI-driven pilot assistance feature, which monitors biometric data to enhance pilot performance, showcases a leap towards integrating human-machine collaboration in combat scenarios. Significance: while many may focus on the aircraft's physical capabilities, the technological advancements represent a paradigm shift in how air combat will be conducted. These innovations could redefine pilot training, mission execution, and overall combat effectiveness, making it essential for defense strategists to consider the implications of such technologies on future warfare. 3. Financial commitment and economic implications. The UK's commitment of £2 billion for the initial phases of the Tempest project and Italy's increased investment to €7.7 billion by 2037 underscores the financial stakes involved. This investment not only reflects the importance of maintaining air superiority but also impacts national budgets and economic policies. Significance: the financial aspect is critical as it influences the political landscape, potentially affecting other defense projects and national priorities. Understanding the economic implications of such investments can provide insights into how countries prioritize defense in the context of broader socio-economic challenges. 4. Modular design and adaptability. The Tempest's modular design allows for easy adaptation to various missions and future upgrades. This flexibility is essential in an era where threats evolve rapidly, and military systems must be agile enough to respond effectively. Significance: the modularity emphasizes the need for longevity in military systems, reducing the need for complete overhauls and enabling a more sustainable approach to defense procurement. As threats change, having adaptable platforms will be crucial for maintaining operational readiness. 5. Cultural and ideological considerations in defense collaboration. The Tempest program's development highlights not only technical and financial collaborations but also the cultural and ideological challenges associated with multinational defense projects. Each participating country brings its own military culture, strategic priorities, and operational doctrines, which can lead to friction or synergy. Significance: understanding these cultural dynamics is essential for the success of international defense collaborations. The ability to harmonize different military philosophies and operational practices can determine the effectiveness of joint projects like Tempest. The implications extend beyond technical cooperation to encompass trust building and strategic alignment among allies. 6. Impact on future warfare. The emergence of sixth-generation fighter jets like Tempest foreshadows a significant transformation in aerial warfare with implications for doctrine, tactics, and strategy. The emphasis on unmanned systems and AI suggests a future where human pilots may play a different role, potentially leading to changes in military training and operational planning. Significance: by recognizing the potential shift in warfare dynamics, military analysts and policymakers can better prepare for future conflicts. The strategic implications of such a transformation could influence national security policies and defense postures globally. 7. Environmental considerations. While not explicitly mentioned in the summary, the future of military aviation is increasingly tied to environmental concerns. The development of cleaner technologies and sustainable practices within the Tempest program could reflect a growing awareness of the need for eco-friendly defense solutions. Significance. As global awareness of climate change rises, the military sector faces pressures to innovate responsibly. Incorporating sustainable practices into the Tempest program could serve as a model for future defense projects, balancing operational effectiveness with environmental stewardship. Conclusion. The Tempest Fighter Jet program encapsulates a confluence of technological innovation, international cooperation, economic investment, and strategic foresight. Each of these areas presents significant implications for the future of military aviation and global defense strategies. By delving deeper into these aspects, stakeholders can gain a comprehensive understanding of the Tempest program's potential impact on future warfare and international relations. Recognizing these often overlooked elements is crucial for a nuanced appreciation of the program's significance in the context of contemporary and future military challenges. 1. Strategic development and international collaboration. The Tempest project represents a significant evolution in defense aviation, driven by the necessity of international cooperation amidst modern geopolitical challenges. The partnership involving the UK, Italy, Japan, and Sweden highlights a strategic shift towards collaborative defense programs that aim to pool resources, share technological advancements, and enhance operational capabilities. This collaboration is not just limited to financial aspects but extends to the integration of various technologies and operational doctrines, creating a more unified approach to future air combat systems. 2. Technological innovations. Tempest is at the forefront of integrating cutting-edge technologies such as artificial intelligence, directed energy weapons, and unmanned aerial systems. The emphasis on a modular design allows for adaptability and rapid upgrades, ensuring that the aircraft remains relevant in the face of evolving threats. The incorporation of advanced features such as a virtual cockpit and cooperative engagement capabilities signifies a transformation in how air combat will be conducted, emphasizing the role of technology in enhancing pilots' situational awareness and operational effectiveness. 3. Financial commitment and economic implications. The substantial financial investments committed by the UK and its partners underline the importance of the Tempest project not only for national defence but also for economic growth and technological leadership within the defence sector. By allocating billions of pounds and euros towards this initiative, the involved nations are not only aiming to develop a next-generation fighter but also to stimulate domestic industries, create jobs, and foster innovation in aerospace technologies. This economic dimension is critical as it aligns military objectives with national economic strategies. For future prospects and challenges, as Tempest progresses towards its 2035 operational goal, it faces numerous challenges, including technological hurdles, budgetary constraints, and the need to effectively integrate contributions from multiple nations. The successful realization of its ambitious objectives will depend on maintaining momentum and development, addressing potential delays, and ensuring that all partners remain committed and aligned in vision. The outlook for Tempest is promising, but it requires a concerted effort to navigate the complexities of modern defense procurement and international collaboration. 1. The Manhattan Project 1942–1946. This was a research and development project during World War II that produced the first nuclear weapons. Led by the United States with support from the United Kingdom and Canada, it involved significant collaboration among scientists, engineers, and military personnel. The project culminated in the creation of atomic bombs that were dropped on Hiroshima and Nagasaki in 1945, fundamentally changing warfare and international relations thereafter. The Manhattan Project exemplified rapid technological advancement under wartime pressure, similar to the Tempest project's aim to develop cutting-edge military technology in response to evolving threats. 2. The Apollo program 1961 to 1972. Initiated by NASA, the Apollo program was a series of missions aimed at landing humans on the Moon and safely returning them to Earth. The program involved extensive international cooperation, technological innovation, and significant investment from the United States government. Apollo 11, the first successful manned moon landing in 1969, highlighted the capabilities of the space program and set a benchmark for future exploration. Like the Tempest project, the Apollo program showcased the importance of collaboration, advanced technology, and strategic planning for national security and prestige. 3. The Eurofighter Typhoon program 1986-present. The Eurofighter Typhoon is a multinational project involving the UK, Germany, Italy, and Spain to develop a modern multi-role fighter aircraft. The program faced numerous challenges, including budget overruns and delays, but ultimately led to a highly capable aircraft that entered service in the early 2000s. The collaborative nature of the Eurofighter Typhoon project, along with its focus on advanced aerospace technology, mirrors the Tempest project's international cooperation and ambition to create a next-generation fighter jet. Future outlook for the Tempest Fighter Jet project. The Tempest Fighter Jet program represents a significant leap into the future of military aviation, aiming to redefine air combat capabilities as we move towards 2035 and beyond. As we assess the future of the Tempest project, several key predictions can be made based on current trends, technological advancements, and geopolitical factors. 1. Technological advancements and integration. The Tempest is expected to incorporate cutting-edge technologies including artificial intelligence, AI-directed energy weapons, and advanced stealth capabilities. By 2030, we anticipate that AI will play an integral role in combat operations, enabling real-time data processing and decision-making. The aircraft's ability to operate autonomously or in conjunction with unmanned systems will likely be fully realized, allowing it to conduct complex missions in contested environments without putting pilots at risk. Furthermore, the integration of hypersonic weapons could provide the Tempest with unprecedented strike capabilities, enabling it to engage targets at great distances and speeds. As countries continue to invest in hypersonic technology, we predict that by the late 2020s, Tempest will be equipped with these advanced armaments, enhancing its deterrence and offensive capabilities. 2. International collaboration and partnerships. The Tempest program has already seen substantial international cooperation, particularly through the Global Combat Air Program GCAP, which includes the UK, Italy, and Japan. Looking ahead, we anticipate further expansion of this coalition, potentially incorporating additional partners like India and Australia. This collaboration will not only distribute development costs but also foster interoperability among allied forces. By 2035, the geopolitical landscape may shift, leading to new security alliances in response to emerging threats. The Tempest could become the backbone of a new coalition air force designed for joint operations among various nations, thereby reinforcing collective defense strategies. 3. Budgetary and economic considerations. Financial investment in defense technology will continue to be a critical factor in the success of the Tempest program. As countries prioritize military modernization amid global tensions, we expect to see increased defense budgets across Europe and Asia. By 2030, Italy's projected investment of €7.7 billion will likely be matched by similar commitments from other partner nations involved in the Tempest project. However, economic fluctuations and potential recessions could pose risks to these investments. Therefore, maintaining political and public support for defense spending will be essential to ensure the program's continuity and success. 4. Evolving threat landscapes. As we look towards the future, the nature of warfare will evolve. With a focus on cyber warfare, electronic warfare, and asymmetric threats becoming increasingly prevalent, the Tempest will need to adapt to these changes, integrating cybersecurity measures to protect its systems from hacking and electronic attacks. Moreover, the drone warfare landscape will continue to expand, necessitating that the Tempest includes capabilities to counter swarm tactics and unmanned aerial vehicles (UAVs). By 2035, we predict that the Tempest will not only operate as a platform for air-to-air and air-to-ground engagements but also as a command and control hub for coordinating drone operations. 5. Public and political sentiment. The future of the Tempest project will also be influenced by public and political sentiment regarding military spending, particularly in the context of climate change and sustainable defense practices. By 2035, there may be increased demand for eco-friendly technologies in military aviation, potentially leading to innovations in propulsion systems and energy sources for the Tempest. As governments balance defense needs with environmental responsibilities, the pressure for sustainable practices could affect the design and operational philosophy of the Tempest, pushing for greener technologies that align military objectives with climate goals. 6. Operational deployment and testing phases. The Tempest is slated for its first flight by 2026, with full operational deployment expected by 2035. As the development progresses, rigorous testing phases will be crucial. We predict that by 2030 the aircraft will have undergone extensive simulations and real-world testing to validate its systems and capabilities. Operational trials will likely include joint exercises with Allied forces showcasing the Tempest's versatility and effectiveness in various combat scenarios. By 2035, we envision the Tempest not only as a replacement for the Eurofighter Typhoon but as a leading platform in air superiority, capable of executing a diverse range of missions. Conclusion. The Tempest fighter jet program is poised to shape the future of air combat through transformative technologies, international partnerships, and strategic adaptability. As we move closer to its projected operational date in 2035, the success of the Tempest will depend on overcoming technical, financial, and geopolitical challenges. Ultimately, if executed successfully, the Tempest could establish a new paradigm in military aviation, reflecting the complexities of modern warfare and the collaborative nature of global defense efforts.